And thank you all for joining us today. My name is Rowan Nadia, and I am a senior member of the communications team here at ACWA Power, looking after external, basically. We are delighted to be with you today to kick off ACWA Power's very first webinar in the Transition Talks series, created to share our technological know-how and expertise with the community and increase knowledge-based awareness of the work that we do. As you know, our theme for today is reimagining the future of water desalination. And we will be talking to 4 leading industry experts to discuss the role of desalination and water reuse in the circular economy. The use of innovative technologies such as big data and AI and other critical aspects that are redefining the desalination sector. But before we begin, I would like to give you all a brief introduction about ACWA Power. And I can proudly say that we are named the largest private desalter worldwide. ACWA Power is a developer, investor, and operator of power generation and desalinated water production plants. And we currently operate in 13 countries across the Middle East, Africa, Central Asia, and Southeast Asia, with 62 plants either in operation, under construction, or advanced development. Our mission is to reliably and responsibly deliver electricity and desalinated water at low cost, contributing effectively to the sustainable social and economic development of these countries that we operate in. So, without further ado, joining us today to discuss the future of desalination, we have our experts, and I would like to start by introducing our guests. We have with us Mr. Roberto Mangano, Managing Director of ILF Consulting Engineers, Abu Dhabi, and Business Director for the desalination projects in ILF. He is specialized in membrane process desalination with professional experience in project management, FEED design works, and tender evaluations. His previous project assignments in water and energy sector include the major desalination plants in GCC countries, such as Rabia 3 in Saudi Arabia, and many others. Also joining us today is Mr. Paul Buis. Paul has over 25 years of experience in the water treatment industry. He is currently Center Liaison Officer for the King Abdullah University of Science and Technology, KAUST for short, Water Desalination and Reuse Center. And he bridges the gap fantastically between academy and industry, facilitating demand-driven research and translating that research to practice. He's an expert in water treatment, in particular membrane desalination. And joining us from our very own ACWA Power, we have Mr. Thomas Altman, who is our VP for Innovation and Water Technology at ACWA Power. He is a leading expert in energy and desalination, having worked in technical and managerial roles in global engineering and construction for over 25 years. Not only that, he is a member of the esteemed MIT Technology Review Global Panel and IDA Global R&D Committee. Last, but certainly not the least, we have Dr. Tariq Nada, who is Chief Technology Officer at ACWA Power. Dr. Tariq has over 20 years of extensive experience in technical and operation management for power and desalinated projects. Dr. Tariq has been with ACWA Power since 2015, and prior to which worked with Saline Water Conversion Corporation and managed several desalination projects. Now we shall begin with a 40-minute panel discussion, what we're all here for today, which will then be followed by a Q&A with our audience. I would encourage you to type in your questions. I see that a few of you have already begun to do so we appreciate your enthusiasm. Just mark them in the question box, and then we will guide them to our speakers in due course. So without further ado, let us begin. And I would like to start with Mr. Roberto Mangano. And the question would be, let's start with the trends. What do you see as the future of desalination in the Middle East? And basically, would reverse osmosis remain the prevalent technology? What are your thoughts?
Thank you, and good morning to everybody. Yes, I would like just to start, in order to answer to your question, analyzing the actual status, the actual world of desalination in the Middle East. In the Middle East, the desalination is led by the reverse osmosis technology. The reverse osmosis technology is a well-established technology, is well-proved. It is used in the Middle East in the last 15, 20 years. And I see that in the near future, this is the technology that is going to be used for the next project that is going to be developed in the region. Together with this analysis, it is important to highlight that in the last 5 years, we have seen a big change in the trend of the size of desalination. We passed from a normal size of desalination of 10 MGD, it's around 45,000 cubic per day, of 10 years ago, that at that time was considered a medium size for a plant, to a different type of scale, speaking about 50, 60 MGD up to 100 MGD. So together with this change in the trend of the size, we have seen also that all the projects, almost all the projects developed in the last 5 years has been developed based on PPP scheme. So all these things happened in the last 5 years, and I see that in the future, this is the trend that is going to be followed. So we're speaking about the big size project, at least in the biggest part of the Middle East. The same scheme to be applied, so a BO or BOT scheme. And this is important because this type of project, when we apply this type of concession, allow technology provider and developer to really achieve as a target a lower water tariff, maintaining reliability of a plant and maintaining also efficiency of the plant. And this is very important because at the end of the day, the procurer, the caller of the plant is looking for this, is looking for a lower water tariff, a lower power consumption, and at the same time, we want to have a plant that is working, that is efficient. So this type of scheme, this type of concept allow the bidder to be more competitive. Another aspect that I see in the future is that is going to be improved also the sustainability aspect of desalination. Sustainability means that it is important from two aspects. The first is from an environmental point of view, and the second is from an economical point of view. So from the economic point of view, it's true that speaking about economic of scale, so having a big plant, this allows the plant to be sustainable in terms of cost. And in terms of environmental aspect, I see that there will be more attention to the bioproducts and also to the brine management. And this is something that most likely is going to open the door to some other technology, not only Vero technology, but also other technology that could allow the technology provider and the developer to treat the brine, reducing the impact on the environment.
Thank you, Roberto. I would like to bring in Paul into the discussion as well, since you brought up the topic of sustainability, and I know that Paul may have some thoughts given the partnership between ACWA Power and KOST. So Paul, over to you if you can share just what your thoughts are and take is on the collaborative effort between ACWA Power and KOST and what has developed so far in the desalination field, taking on from what Roberto has just shared with us.
Yeah, I think, Rowan, the main driver for the recent developments has been the fact that Vision 2030 clearly states that subsidies for energy and water are going to be diverted to those who need it, and that meant the energy tariffs for these independent water producers were up to, let's say, a real tariff, a realistic tariff, and this immediately led to better designs. designs with lower stress on the membranes, maybe a bit more membranes. ACWA Power has been particularly successful in that, but it really did not change too much the process that happened on the membranes. And this is what we're working on with ACWA Power currently. Yeah, because we actually really want to change the desalination process using membranes by using less chemicals, using the right chemicals. That is also the case currently. We are very much convinced that the industry is not using the proper chemicals that are used currently to reduce fouling. They actually promote fouling. Yeah, this is costing energy, and this is costing cleaning, reducing the lifetime of the membranes, and so on. So what we're working on together is actually to find that optimum use of chemicals, minimum use of chemicals, but do it right. And also look at things like if you're cleaning, use the proper cleaning chemical and then reuse that cleaning chemical so it isn't discharged to the sea. So there are many aspects of the desalination process that still can be improved. So far, it has been primarily a very smart engineering exercise. And it's time, basically, it's our responsibility that science keeps up or leads the engineering exercise. So that's roughly what we try to do together.
Great, thank you, Paul. So on that note, could I ask Thomas for your opinion, since we mentioned basically ways to improve efficiency, plant efficiency. Could you talk us through a little more about that?
Yes, thank you, Ruben, and good morning to everybody. So yes, I think this is one of the things we are very focused since the second round of IWP started around 2017 with the RABIT project. What we saw is that compared to our previous projects, which was like Schwaber expansion 2, from 220,000 cubic meter to 600,000 cubic meter is a big jump in one plant. And at the same time, the cost of electricity has more than doubled in Saudi Arabia from, I believe, 2.1 cents per kilowatt hour to 4.8. And so it was clear for us we cannot just simply continue with a low capex approach. We need to look into the operation, we need to look at the life cycle cost approach, and we need to cause a paradigm shift in the design of our plants. And that's what we tried to do in RABIT as the first plant. And we worked with OEMs, we worked on the way we designed the plant and continued this into Gorilla. So basically, there's a few pillars what we have done. First of all, of course, pump the main pumps are a central part of the plant. So we made sure that we are operating the largest power users most of the hours of the year at the highest efficiency point, which is logic. And then we built the RO system around it. But we did, I think, a very extensive exercise in finding the right membrane selection and membrane configuration. This was thousands of simulations rather than a few simulations to get to this point with the right balance between first and second pass. I think we presented a paper on the last IDEA World Congress in Dubai on that one, and it was also rewarded for this exercise. And it led to a really 25% lower power consumption than the previous plants. Another important pillar to that was that we introduced the concept of big data analytics. I haven't seen that much before in the desalination world, but we also, ACWA Power is also quite involved in the renewable sector. And here it's very much standard to use solar resource assessments and to optimize your yield generation, your power generation yield. And so we try to apply that on the seawater side by creating from a typical meteorological year, which is used in renewables, a typical seawater year. So we were in the lucky position to have years of seawater data from our existing plants. We analyzed that, and we were able to find another level of optimization rather than going with the simple analysis which is provided in the RFP. We had years of data which we defined an operation limit within the design envelope, and this allowed us to go another level deeper in the optimization. Then we found concepts to increase availability and increase the pump sizes. And so after that, there is room for using new technologies like the AI technologies. So we did investigate very deeply in how to use machine learning, deep learning, and artificial neural networks. We found some applications which we found have a potential, and we are running this kind of codes now to help us to save, for example, chemicals. At the end, we are a developer, not the university, so we will not follow everything which is published. We have to pick the one which we can see a bottom line impact in a very short period of time, and that's what we try to do.
Thank you.
Yeah. The next level basically was after Rabbit to include solar in the desalination plants to assist and to reduce the amount of energy you're buying from the grid.
Thank you, Thomas. Okay, so can I ask Dr. Tariq Nada for your thoughts, since we are discussing as well, managing of life cycle cost and a different approach to obviously looking at over the term how to mitigate or reduce costs. What do you feel in terms of planned preventive maintenance measures could be applied, and what are crucial to sustaining short and long-term operations of the plants? Dr. Tariq?
Yeah, thank you, Rowan, and thank you for my colleagues to put everything on the table, left me with almost very little to add. I will start from the thermal desalination. Although we don't see it now coming as a new plants, but we have some considerable plants running and still have some 10 plus years in each term. So for those thermal plants, there is an area of further improvements from O&M perspective in the area of anti-scalants, especially for those distillers running at high top brine temperature of 110 and above with a large scale of production. So for thermal, there is an area for the anti-scalant, and it can be customized for a plant to a plant. Going back to the RO, which is almost now dominating the market, as mentioned by my colleague, due to its significant lower life cycle cost, still some area of improvements in the RO membrane stabilities and its cleaning techniques. As Paul was saying, that cleaning techniques is not almost mature, and still some areas of further exploration to find the best, and it can be again customized. What works in X side cannot work over there. So we need, as a developer and operator, to co-op with the R&Ds and OEMs and the vendors to come with the best to serve the market. Also for the membrane itself, we know that the typical life of any membrane is now something 5 years plus or minus. We need again to work with them more particular in extension of the life of the membranes. It can be not the best scenario for some vendors, but it is the best for the overall industry. Also, one very important part of the big picture to further fine tune is the pumps efficiency and its motors. It plays a big part of the overall power consumption of the plants. Now we see some running plants touching the 3 kilowatt hour per meter cube, and some claims in the market of lower than that. If we need to reduce more of a 0.1 or 0.2, which is significant, it will be more of working on the pumps efficiency and increasing the efficiency of the energy recovery devices. So to summarize, as of now in seawater desalination, as Paul was saying, engineering is one step ahead of RO. Hence, we need to co-op and bridge this gap by supplementing the R&D arms with industrial gap analysis. And I think this is what exactly ACWA Power is doing with KAUST to enhance and find another areas of improvements.
Dr.
Yes.
Tariq, you have set this up perfectly for me now, because I know this is one of the questions from our audience that came through as well, that I think I'll just bring in here, since we're on the topic of the quality of membranes and brine reduction. What would you say, and I will take this to Paul and Thomas for your views, what has the experience of Middle East been so far with mitigating brine reduction?
So yeah, Thomas, maybe I shall go. I think so far it has been very limited. We must not forget that brine only has been a topic for, let's say, the last 2 years, mainly brought in the spotlight because of the goals of the Red Sea Development Company to have a total zero discharge. And we're not talking zero liquid discharge. They have a zero discharge for the full project. Yeah, and then meaning, certainly their environmental goals are very strong. So zero liquid discharge from the desalination plant is one of the strong goals. But let's not forget that reverse osmosis has come a long way. Yeah, 50 years. Yeah, and from 50 years, it's evolved from a capacity of 1,000 cubic meters per day per plant to roughly 1 million cubic meters per day per plant. So to bring the technology that is partially available to where we want it to be is going to take a long time, even though we can speed it up, but it's going to take a long time. On the other hand, we must not forget that for every cubic meter of water we deliver as a product, we have 40 kilograms of salt. And even parts of that salt have a value and can be sold, but it still will result in a residual that cannot be sold. So this is a problem which needs a lot of attention. Yeah, to put it very simple as the salt will pay for the desalination, I totally disagree with that. Yeah, there are some that make that statement. I think in future there will be more value coming out of the brine. So there are opportunities for that. But we will result in a residual because all our activities will result in a residual. And the other thing is, one thing we cannot solve is the laws of thermodynamics. Yeah, at the end, we'll pump in so much energy that it becomes less affordable, yeah, and less realistic. And also to strive fully to zero liquid discharge will have a extremely negative impact because of the energy input that is needed. And there's an end to what we can do with renewable resources for energy. Yeah. So it is good. It gives us at least another 10 years of research projects to get anywhere.
Thank you, Paul. I mean, so since you raised a very important point about renewable energy as well and its role, perhaps Thomas can now discuss with us as well, how do you see that trend and obviously the role of storage, playing a big part as well in energy conservation and distribution?
Yes, thanks, Roman. Let me just add one point to the Brine story. We are observing, obviously, the upcoming discussions since a year or two. It's getting very hot about Brine. From the developer point of view, it's a rather simple view. We can only do what is economically viable, and all the analysis we have done really shows that the energy consumption is much higher. The cost is not justified yet. Even the discussion of less treated materials in reality, when we do these projects, we know the costs, and we haven't done it yet. So there's a reason for it. But the bigger reason for that is there is not a single RFP for IWP. So if we as a developer, we respond to tenders for RFPs, we don't have a single RFP in our hands where there's a request for brine concentration, so we can do it if we want. And there is no change in law as long as there's no change in law which forces off-takers or off-takers quoted in the RFP to deal with this topic, it's an add-on which is not economically viable. But on the other hand, we are aware of these technologies. We expect it will come sooner or later to look at brine, I would say minimization, because there's a big difference if you reduce the brine by 80% or 100%. I think the last 20% will take a lot more energy than the first 80%. So it's also from a developer view, it's maybe a little bit different than from a scientific view what you're doing. So we are looking at these technologies. We also see that despite the high energy consumption, some of these technologies can be partly driven by solar. And there's an abundant solar irradiation in Saudi Arabia, for example. So we are factoring in that point. But the key point is we need an RFP which asks for it and provides the basis for it. This will come with another complication which Paul partly mentioned. We need an off-taker for the salt. Somebody has to buy the salt. And so there will be now a long discussion of the salt market. But we do that in our power plants. Sometimes we also have to buy the fuel or sell other things. That's fine. We can definitely handle that to sell additional products and additional revenue streams. And so finally, the combination with solar is interesting. The salt extraction is interesting. Once the RFPs will be there, ACWA Power will be ready. We have done work on that. Our work is based on patents from almost 20 years ago, because it's based on nanofiltration. And nanofiltration is nothing which was invented yesterday. Nanofiltration for seawater desalination in front of an RO plant. We have within ACWA Power access to patents, which is still valid, and allows us to utilize that. And I think many other developments following this trend is in nanofiltration, which basically splits two streams, one for the bivalent ions and one for the sodium chloride. And we fully understand what does it do to the project and how we can further optimize the roadmap. So in summary, if an RFP comes out, which requests brine concentration, we will be ready. And we have also with a partner, we have an active pilot plant running for brine concentration.
Great, okay.
Solar, the second question, I don't have to escape. Solar, okay, I think also for us, we are looking at large projects, so we are not involved in the design of small island systems, so we need to focus on that one. We have shown as the first developer to deploy a large solar plant within a desalination plant. That's in the largest RO plant in the world, which is Taurila. We need to just highlight here the point that the solar component doesn't do anything for the energy consumption. The process stays the same, the energy consumption of the RO stays the same. All it does for us, we are procuring less power from the grid. That's it. So,
thank you.
So it's integrated in a way from a construction point of view, but not from a process point of view. There are technologies out which we are interested. And again, we are interested in the solar-based technologies like a low temperature CSP, and there are some other developments which we're interested to combine with technologies which utilize a combination of heat and electricity. One example for that would be the forward osmosis technology, where the electricity consumption is less than half an RO, plus the process heat, which can be produced by solar. So that's, again, something we are looking into it. We will be ready when the tender is out. Unfortunately, same situation like in Brine. There's no RFP coming out. There's no development going on. And so a lot of time is going, is passing, and no reference projects are created. I think this is, we would highly appreciate to see some RFPs coming up in this respect. And again, we will be ready when the RFP is out to respond accordingly.
Absolutely. Thank you, Thomas. So I'd like to, on that note, bring in Roberto to discuss the IWP tenders and what are the main criteria to evaluate these tenders, in your opinion? I know that ILF has worked closely with ACWA Power on Altavila, so I think this is a good fit and opportunity to discuss.
Yes. Actually, when we speak about the WP tender, we're speaking about the completely different requirements compared to the a normal PC basis tender. When we evaluate an AWP tender and we specify the requirement, we need to take into consideration several factors. The procurer of a plant is looking for a lower tariff, is looking for a lower power consumption, but at the same time wants to be sure that the plant is going to work for the next 25, 30 years. So this is something that has to be put all together in terms of requirements. The project is to be bankable. So this means that we cannot, as an entity preparing RFP together with the governing authority, we cannot rely on technology that sometimes are not proof. And this means that we need to maintain requirement linked to a state-of-the-art technology like RO. At the same time, we need to consider that the developer, the project company, is going to take also the risk of this project, is going to maintain the plant for the 25, 30 years. And this means that we should allow also a sort of freedom for the developer to improve the efficiency of the plant. Improving the efficiency means that, of course, we could allow to the developer to enter and propose some new technology, but at the same time, we need to be sure that we define a very clear and correct design envelope. As I said by Thomas, it is true that each RO system is sensitive to the water that is going to be treated, so is sensitive to the location of the plant. And this means that once we are preparing the AWP tender, the consultant needs to be sure that the tender is customized up to the location of the plant in order to be sure that we can really have and collect all the benefit from the RO technology that is applied to that specific location, treating some specific water. This is something that is important. This requires time, and this is the reason why every time that there is an AWP tender, there is a specific feasibility study, concept design study before to go to the market asking for developer to provide a solution.
Okay, thank you. Paul, so over to you then, since we're saying that, essentially this process could be a little bit expensive as well. Could you maybe discuss with us the environmental impacts as well? And, how do you see the environmental aspects being tackled in countries that depend on desalination to satisfy demand?
I think, well, first of all, to make the bridge to the tendering process, we must also not forget that the risk averseness of the end user also means that it's sometimes very difficult to introduce innovative designs in the tenders. So I would say the end users like the Red Sea project and NEOM, they are actually playing a very important role in actually building that experience that is needed to be accepted in the large scale project. So that is the one aspect. The other thing is, if we look at brine is concentrated seawater plus the chemicals we added to it in the treatment process. So one of the biggest problems is actually the presence of these chemicals that are alien to the sea body, to the marine environment that we put it back in. So one of the things we're eager to do and are also doing in the work we're doing with ACWA Power is actually to reduce the chemicals that are used or replace them with chemicals that have less impact. Yeah, so that until we are there to do a full-scale reuse of brine or materials in the brine, we already start improving the impact to the environment or reducing the impact to the environment by eliminating those chemicals. I think that is a very important first step. And that applies to what we're doing in the pre-treatment in terms of the use of coagulants, the use of biocides, but also what we do in terms of antiscalants. Yeah, looking to reduce the phosphonates, so the phosphate content actually contributes to algae growth into our water bodies, which is actually, we are self-contaminating our source in that way. So that is a good reason to start eliminating that. And we're also looking to the quality of these products because, as I said before, some of these products actually cause fouling on the membrane. So that requires extra cleaning. That means extra discharge. Well, so a lot of activities that we're doing are reducing the impact on the environment before we are ready to do a full-blown zero liquid discharge system. I think it's very important to do that because let's say we are dealing with contracts now that are running for 25 years, so there is no obligation in the existing contracts to do any work on zero liquid discharge. So all the impact we have on the existing installed base is very important. Yeah.
That's very helpful. So maybe on that note, it would be helpful to also explain to the audience. I know someone raised a question earlier about the difference, just going back to the basics on the difference between forward and reverse osmosis and what are the benefits of each. If you could recommend any particular one, or in what instance would you recommend one or the other? And Thomas, maybe you'd like to take a call on that one.
Can I make just one comment to the end of Paul's?
Absolutely.
Reducing chemicals, we just introduced recently used carbon dioxide to inject it in seawater. And this is why we do that, because obviously people will argue that we are not acidifying the seawater anymore. It was an old plant, but first of all, we disagree that disinfection and coagulation and the pre-treatment works better at the higher pH, but this is a different story. Why we do it is, first of all, it reduces the carbon footprint. The CO2 is not only reducing the pH, it is also helping working as an antiscalant agent. So we have several effects from lower pH, better disinfection, lower pH, we have a better coagulation, that's all documented. We can replace the antiscalant with the CO2. Additionally, we can look at higher recoveries. Also important, the CO2 as a gas is passing through the membrane 100%. There's no rejection. That means the CO2 consumption, which is used from food-grade CO2 in the post-treatment, can be reduced, typically by more than 10 ppm. And also in the brine, we're talking a lot about brine concentration and brine minimization. A lower pH is beneficial here, and also by putting the CO2 in the seawater to get all these benefits, you also have a lower pH in the brine. So this is just to round up what Paul said.
Okay, great, thank you.
So what is the other thing?
So we have a couple of questions, or quite a few questions from audience. I'd like to start channeling them as well into our discussion. So I'll start with this. In terms of, and I know you touched on this just now, Thomas, maybe you can build on it for Mr. Wasim Raja, who asks, in terms of early warning sensing systems, what type of work is ACWA Power doing?
Early warning systems.
Early warning sensing systems, yes.
So the first thing we do is I will not go back to the standard, let's say, calibrations and improvements. What we are doing, we are looking at the complete holistic approach to apply for the RO monitoring, applying AI technologies on every corner, which makes sense, and use these signals and information to generate this new information, which will give us this intelligence, which will allow us to act early. So we predictive analytics. Very important is here that the first analysis we did, we call it AI readiness check, which we did in our plants together with Paul's team in Kaust. The first thing we found out is that we don't have the right sensors. Well, we have some right sensors, but not all we need. And so the one focus of the R&D with Kaust is focusing on adding new sensors, which at least as far as we know, do not exist today. And there is a particular department in KAUST which is focusing on sensor development. And so we will use that to get additional very valuable information which will help us to better understand what's going on in the membrane. Some sensors can be in the membrane, some sensors can be around the membrane. Very basic things we see is that sometimes the conductivity of the feed water which goes into the membrane is measured on the wrong point. It's measured before the high pressure pump. So what it simply means, you measure the wrong temperature and you measure the wrong conductivity if you have a two-stage system. Because first of all, the high pressure pump increases the temperature, and second, the blending from the second pass brine is changing the salinity. So let's fix that one. That's the low-hanging fruit. Then we look in the other values, other measurements which we don't have today. And together with that, using, again, these technologies from machine learning, deep learning, artificial neural networks, together, based on a lot of data, will help us to see new patterns which humans cannot see. And our strategy is clearly the combination of artificial and human intelligence, which we call collective intelligence. And that's the approach which we try to implement. We're already running projects in our plants, and I hope we can further improve the aroma monitoring system and with predictive analytics, and to take actions early.
Thank you, Thomas. So we have a question here for Paul. That is, NEOM has announced last year for the construction of the first desalination plant with solar dome technology. Do you believe that this technology could be used widely in KSA and would prove more advantages and development in water desalination? This is from Mr. Abdul Rahman Yusuf, and a question to Paul.
Well, the thing is, believing or not believing, that doesn't come into it. I might have opinions on that, but I think it's a bold move of NEOM to start proving this technology. Yeah, and we'll find out. Yeah, we have to be open-minded for this. Yeah, there's part of it that honestly I don't understand yet. Yeah, one of the things is I do understand that by putting in the solar heat, you get the evaporation. The condensation part, I do not yet understand. So the collecting of water. But again, you need companies like NEOM, you need the Red Sea Development Company and things like that to try to disrupt the technology and to do things that a lot of people think that they cannot be done. Yeah, there's like solar dome, you also have the air to water concept. Yeah, so one of my friends who is an artist, he is actually making huge steps in air to water. These things will find a place. They will find a place. So this is, when we're talking technology, it is almost like technologies are competing against each other. That is certainly not the case. I want to stress that RO will do the big plans. And there are niches for other technologies. Forward osmosis is also strongly coming up. So there is room for a lot of technology in the field of desalination. I personally think that remote small communities are very much underserved. Yeah, so there is room for technology for that as well. Yeah, so KAUST is also working on things like that, like the combination of a solar panel with membrane distillation. Things like that deserve to be tested, to be followed critically as well. Yeah, but they will not replace Rabic 3 or Jubail 3A. They will work on a smaller scale.
Thank you, Paul. So I know in some part you may have also touched on our next question, which is from Verity Ratcliffe, which asks, KSA plans to produce 50% of its power from renewables by 2030. What impact will this have on existing desalination plants in the kingdom? And I will request for Roberto Mangano, perhaps, to give us a perspective with a consultant's hat as well on.
Let me see if I understand the question. We're asking what is the impact on changing the production of power from a conventional system to a renewable energy system. What is the impact on the desalination industry? Correct?
Perhaps, yes. So it's basically
so
the split.
What I see, it is valid also for the. It's not valid only for the Saudi Arabia, but also for other countries of the Middle East. We're speaking about transaction between one type of sourcing of power to the other. And as I said before, nowadays the road desalinations, the reverse osmosis system is leading the market of desalination to produce drinking water. However, in the past, the drinking water was produced by thermal technology, so multi-stage flash, for example. And this type of technology that were produced in drinking water were connected in cogeneration with power plants that are based on fuel system. So going from a generation of energy from a fossil fuel system to a renewable energy system means that part of the old power plant will be dismissed, will be demolished, together also with the part of the system that is producing water, that is mainly a thermal technology system. This means that together with the transition from fossil fuel power to renewable energy power will be also a change in producing drinking water from thermal system to reverse osmosis system. So this, I think that is the view when we speak about the big size in terms of production of water. Of course, when we speak about a lower production scale, it is true that it could be possible that together and in parallel with reverse osmosis, we will see also other technology to be used to produce the drinking water. But this is what I see. I see that the transition from power is going together with the transition from thermal system to reverse osmosis system.
Thank you, Roberto. So we have a question here that relates to OEM, and I'd like to bring Dr. Tariq Nada into the discussion. Dr. Tariq, Ms. Nahad Shauki says, looking for a lifetime reliability and maintenance of efficiency level is not possible without proper O&M service contract. Is there any scheme for that? This is from Nahad Shauki.
Yes. I do agree 100% with the statement, and it is something to start. The whole process to have a full cycle starts from the engineering part. We have to engage our O&M team since engineering stages all the way to construction and commissioning, and we invite the OEMs of each main equipment to facilitate training for our O&M crew on the site. And again, it is customized site to site, depending on the OEM. And by time, we develop the O&M activities according to the OEM development within the market. And we review this on a timely manner, sometimes depending on the equipment itself, 2 years, 3 years, 5 years. So we work with the OEM themselves to develop the O&M practices for the best of both. And if the equipment itself requires an external contractor from the OEM himself or someone he would recommend, we would go for this. So it's a matter of a full life cycle from engineering all the way to running the equipment.
Great, thank you. Okay, so I think we have time for just a couple more questions, and maybe Tariq, if you could stay with us and maybe touch on a little bit between the combination of CSP and PV. This is a question from Diego Cesar Padilla, who asks, can a combination of CSP plus PV be the solution for almost fully decarbonizing the new big RO projects? And I will leave this between you and the rest of the group who would like to contribute to this question. Dr. Tarek, if you would unmute your microphone.
I'm not getting the question. Can you say it again?
A combination of CSP and PV, would it be the solution for decarbonizing of big RO projects?
Okay, let me start with a fact, which is the source of energy, whether renewable or none, keeps the specific power consumption constant, i.e., if we are using CSP or PV, it does not say that we will reduce the specific power consumption. This is a fact. What source of renewable to use to combine with the grid connection is something usually controlled by the allocated land in the RFP. So to go on a CSP or a PV, it is just it's a matrix of so many elements coming together to define what is the percentage coming from the renewable and what area allocated for this.
Thank you. And maybe if
I think Thomas
unless
needs to add something.
Of course, Thomas or Roberto, if you would like to.
What I would say, maybe I can just add that if you look at from the point that desalination a baseload energy supply, then the question is in this respect very good, because the CSP plus PV is a powerful combination. We are just now constructing in Dubai the largest CSP and PV plant combination in the world, with I think 900 megawatts in total, which has both components, and which is able to provide a baseload. On the one hand, from the CSP with the thermal energy storage, plus the support from the PV, which on the day particularly reduces or provides the electric power to the CSP and also for export. So that's a very good solution. CSP prices have come down dramatically, as we have seen from very high levels 5 years ago, 6 years ago, and now we're at I think in the 7-cent level, and it can be even lower. And the combination of it is probably in the 5-cent level. And there will be more developments, but this is one option. And if you have a grid available, you can also use an oversized PV plant and this export power to the grid on the day and get it back in the evening when the PV is not producing energy. So there are several models, business models available how you can combine renewables. And the third one is to use energy storage, which you probably asked before and we didn't reply properly. So the combination between the renewable intermittent supply and the baseload desalination could be the energy storage. And there's interesting concepts out. I mean, we all know batteries are maybe not for 24 hours the optimum solution at this point, but we're also looking at kinetic energy storage solutions like the energy vault, Brines, and this kind of solutions which can convert intermittent renewable energy into a baseload power for our plants, for example. And so yes, that's for sure the way we are thinking to get desalination plants completely driven by renewables.
Great. Okay, thank you. So I think we have time for one last question and potentially also have some closing notes from each of yourselves. So I'll start by Paul. Paul, would you like to say a last few words for us, perhaps, on the role of big data and AI? I know this is also a very topical area, given that we're discussing reimagining the future of water desalination. So we'd like to hear your thoughts there, and I'll just go around the virtual table for a final conclusion before we sign off for today.
Yes, thank you. I think for me personally, big data and AI provide an excellent opportunity by now to learn from what we have been doing already for 30 years. Yeah, and that there's not been possible so far. Yeah, so I recall the early attempts of fuzzy logic and so on that really didn't bring us much. But now this is a great opportunity. Moving forward by looking back is good. Moving towards let's say a real-time extra eye for the operator. And let's not forget the human capital part of it. This is also important. We're doubling the size or the amount of water that we're producing. This requires a lot of people, and there's going to be a shortage of human capital for desalination technology. And AI needs to help us with that as well.
Fantastic point. Tarek, Nada, if you would like to add anything as well from your perspective and perhaps from Saudi as well.
Yes, I would like to say thank you. That was very interesting kind of talk. And I think maybe next time we plan it for more time because I believe you have much more questions. I will just wrap it up again by saying as of now, the area for the development in the near future is further improvement in more performance robust membranes, pumps, and energy recovery devices. And as Paul and Thomas are saying, biofouling control and minimizing the chemicals. And lastly, we would be working to taking the maximum profit of renewable energy, whatever is the source, controlled by the maximum area for an allocated land. Again, thank you so much.
Thank you, Dr. Tarek. Pleasure as always. And Roberto, some of your conclusion, thoughts, and takeaways from today.
Actually, I see that based on the discussion of today, it is clear that the desalination industry is moving forward to a more sustainable solution. So we're speaking about brine management, we spoke about byproduct management, at the same time use of new power source, renewable energy, and at the same time also innovation, how to announce the efficiency of a plant. And I see that all these topics are part of the discussion of today, but also part of the discussion nowadays in the industry. And I have to see that one of the main leaders of this, how to say, improvement in desalination is ACWA Power, that is one of the main players in the desalination industry.
That's very good to hear, and thank you, Roberto, for that lovely closing note. Thomas, over to you for a final summary.
Yeah, thank you, Rowan, for moderating that, and thank you to the audience for attending. This was very interesting. So basically, what we can see is here we had a phase where desalination plants were driven by low capex. This was, let's say, the one generation of plants. This ended probably in about 2017, where we had the second wave of IWPs in Saudi Arabia, and it was very well managed. And the results from this from the second phase are very significant reductions in cost and in energy, which is very good. And so the last few projects were very much focused on further optimization on every. What we say, we turn every stone in order to optimize to the maximum and to be able to compete. This is now, let's say, pushed to the limits in terms of equipment, in terms of fine-tuning, optimization. There's still room for a proper performance model simulation program for RO because it doesn't exist in a proper way. So we're working with that. But I see now the next generation of desalination plant optimization is coming, which we have discussed with all these AI technologies. But also I see that there's more and more interest generated now to valorize the brine. And so we will continue our relentless efforts to provide, to contribute to the desalination community with further improvements. And whenever this brine and this comes in the RFP, we will be ready.
Thank you so much. So once again, I'd like to say thank you to our speakers for being so generous with your time and the insights. We hope that our audience has enjoyed it, and we hope that we've addressed as many questions as we could in the time that we have. It also means that we just have to stay tuned for more. So thank you once again to our speakers and audience for being with us today. Have a lovely afternoon, and Ramadan Kareem to all of you.
Thank you.